Practice problem 3 involves finding the height of an antenna and with a shadow that's measured on the side of a hill. Okay, notice a couple things right off. This problem is given in metric units, and whenever you have metric units, you should stay with metric units. The other thing to notice is that one of the angles involved is not given as a direct angle, it's given as a triangle with a 1 to 5 slope. That is, whenever you move 5 units horizontally, you move 1 unit up or down depending on the direction. So let's begin this problem. The approach to this problem is to find the height of the antenna in 2 pieces. Y1 will be based on this triangle, Y2 will be based on this triangle. Both of these triangles are right triangles. I know this side is 32 meters. And I know that this triangle has the relationship 1 to 5. So our first job is to find this angle, which will also be the same as this angle, because these are both straight lines. So any angle here has to be the same as any angle over there. Let's begin with that. I will call this angle theta, which means this angle is also theta. This is 1, this is 5, and therefore the tangent of theta equals 1 over 5, opposite over adjacent, or theta equals the inverse tangent of 1/5, which equals the inverse tangent of 0.2, or theta equals 11.3099 degrees. The next thing I'm going to do is find the lengths of these 2 sides. Degrees. I'm going to find x and y1. Based on the simple relationship between cosines and hypotenuses, x equals 32 times the cosine of 11.3099, and that equals 31.3786 meters. Y1 equals 32 times the sine of 11.3099, and that equals 6.276 meters. The next triangle I have to solve is the upper triangle with y2. This side I just calculated is 31.3786, and I could calculate this length, but I don't really need to, because I know that y2 over 31.3786 opposite over adjacent equals the tangent of 55. So the tangent of 55 degrees equals y2 over 31.3786. And solving for y2, getting it all by itself on one side of the equal sign, I just move this from the bottom to the top on the other side of the equal sign, 31.3786 times the tangent of 55. Now I've got it in a form that my calculator can easily solve. And I see that y2 is 44.813 meters. Now my height of my antenna is y1 plus y2, 6.276, 44.813, or the antenna height is 51.09 meters. You could have also done this problem using some of the other triangle relationships, the sine law or the cosine law. That just involves a little more figuring, and the calculations are a little bit more complicated. I always recommend trying to stay with right triangles when you have the opportunity. And that's all for the triangle problem 3.